Questions, okay, completed. Right, children, in this class, let me discuss about the so enthalpy of reactions means types of enthalpies of reactions. Let me discuss, children. What is enthalpy? Children, tell me what is enthalpy.
Heat of a system at constant pressure.
Heat contained by a system at constant pressure is called as enthalpy of a system. Enthalpy is intensive property or extensive property? Tell me, children.
Extensive property.
Extensive property. State function or path function?
State function.
State function.
So, by determining these enthalpies, enthalpy means heat change during the chemical reaction. It can be explained on the basis of thermochemistry. So that we have to discuss about the thermochemistry. Thermodynamics part is first law of thermodynamics. Enthalpy is related to the first law of thermodynamics. So that all these enthalpies, different types of enthalpies are related with first law of thermodynamics. So that we are discussing under the first law of thermodynamics. After completion of the all enthalpies, again we shifted to the thermodynamics, means second law of thermodynamics. Right, children? Now let me start. Thermochemistry. Yes. Thermochemistry is a branch of physical chemistry. Thermochemistry is a branch of physical chemistry. Branch of physical chemistry. Physical chemistry. Branch of physical chemistry. Okay. Which is concerned with energy changes. Which is concerned with energy changes between chemical system. Energy concerned with energy changes. Energy changes between chemical system with surroundings. Okay. When a change of phase, or a chemical reaction takes place. When a change of phase, or a chemical reaction. When a change of phase, or a chemical reaction. It's clear, children, what is its mean? Just 1 second, no? Write down meanwhile. Children, copied now?
Yes, sir.
Copied. Right. Thermochemistry. Thermochemistry is a branch of physical chemistry which concerned with energy changes between chemical system with surrounding. Chemical system with surroundings. Surroundings means when the chemical system change of phase. Change of phase means H2O, okay, na? Solid to H2O liquid. Okay, no? What is the energy changes during this phase change like this? Or chemical reaction H2 plus O2 gives rise H2. This is chemical reaction. During this chemical reaction, what are the energy changes you are observed can be explained on the basis of thermochemistry. This energy changes during the phase transformation means solid to liquid, liquid to solid, solid to gaseous, gaseous to liquid, whatever the phase changes, energy changes is also dealt with thermochemistry. Children, it's clear?
Yes, sir.
Yes, sir.
Yes. Let me continue. Now, let me write about the thermochemical equation. Thermochemical equation. Thermochemical equation. What is the thermochemical equation? What is its use? Okay. Thermochemical equation means a chemical reaction. A chemical reaction. A stoichiometric. Stoichiometric. Balanced. Balanced. Chemical. Chemical equation. Okay, na? In which their physical states their physical states their physical states can be expressed by subscript of okay, no? Formula or symbol. Formula or symbol. Okay, and finally change in enthalpy. Change in enthalpy can be expressed. Means change in enthalpy means the energy changes simply the energy changes and finally energy changes and finally energy changes and finally energy changes can be expressed in terms of change in enthalpy. Change in enthalpy. It's clear, children. This is the rule for write the or expression of thermochemical equation. That means a stoichiometric balanced chemical equation in which their physical states can be expressed by subscript of the formula or symbol. Finally, energy changes can be expressed in terms of energy changes. Okay, na? In terms of enthalpy change. It's clear. Change in enthalpy called as okay thermochemical equation. Let me take the one more example for this one. Children, copy now.
Yes, sir.
1 minute.
Clear. Clear now.
Sir, last one.
Completed.
Sir, last one.
Yes, sir.
Completed.
Yes, sir.
Okay, right. Going to the next page. Right. Children. Now, example what I'm taking here. Example taking here. For this example, hydrogen is in gaseous state, H2, must express in physical state, combines with half mole of oxygen, gaseous, to forming the H2O in a liquid state. So element symbol subscript to their physical state. This is complete balanced equation. And this energy changes can be expressed in terms of delta H. Change in enthalpy is equal to, okay. For this reaction, how much amount of energy? For example, 240, okay, na? 9, 249.0 kilojoule per mole. 1 mole formation of H2O from gaseous hydrogen and half mole of gaseous oxygen when it is forming the 1 mole of water in liquid state. Now, this much amount of energy is released. The energy released in expressed in negative side. This is the one more example. Example 2, I am shifting to the example 2. Now, mercuric oxide, HZO, which is in solid, 2 moles, I am heating. So, decomposed to HZ, 2 moles, which is in liquid state, plus gaseous oxygen, O2. For this reaction, compulsory ending of reaction, the delta H can be separated by semicolon children. Remainder. This is 180.4. Delta H is equal plus 180.4 kilojoules of mole inverse. It's clear now? It's clear.
Sir, once again explain the meaning of negative and positive, sir.
One, sir?
The meaning of negative and the positive, sir.
Mercury, this one, huh?
Not, sir. Here, plus 180 also and minus 240.
It will be explained in the next, just reminder. Okay, na? This is the representation of thermochemical reaction. So why we are giving the negative sign, why we are giving the positive sign, I will explain in terms of the exothermic and endothermic reaction, that it is enthalpy of reaction చెప్పేటప్పుడు explain చేస్తా. It's clear.
Okay.
Factors about the important features అవసరం లేదు తల్లి మనకి factors that are affecting the enthalpy of reaction or heat of reaction, right? Now, first, before going to discussion of this one, why we are giving this energy changes, okay, based on the thermochemical reaction, there is in 2 types based on energy exchanges between the system to surrounding. So that based on energy changes. Energy changes between system and surroundings. Okay. Chemical reactions are in a chemical reactions. Reactions are in a two types. Banu joined na? Banu, did you join the class?
Join, sir.
Okay. Right, children. Based on energy changes between the system and surroundings, chemical reactions are in two categories or two types now. So one is a exothermic reaction. Exothermic reaction. The second one is a endothermic reaction. Right. What is exothermic reaction? What is endothermic reaction? Let me discuss it. So first, let me discuss about the exothermic reactions. Tell me, children, what is exothermic reaction? Do you know?
In which heat is released is called exothermic, sir.
The reaction in which or the reaction employed or accompanied the chemical reaction
In which
or
heat is given off, sir.
reaction is employed or given off. Employed by liberation of heat. By liberation of heat to surroundings is called as tell me, children, exothermic reactions.
Sir, liberation of heat, sir.
Liberation of heat. Yes, heat. Liberation of heat to surroundings is called as exothermic reactions. It's clear, children. So let me take the one more example for this one. Okay. Completed the page. Copying. Children, tell me.
Sir, 1 minute. 1 minute, sir.
Clear. Right. Going to the next page.
Come, sir.
Did not completed, no?
Completed.
Completed. Yes. Thank you. Now, I am taking the one more example. In the previous example, what I take, children? H2 hydrogen gaseous state combines with oxygen gaseous state to
Lime
forming.
plus CO2, sir. Lime plus CO2 releases heat.
Yes. That is also one more example. C plus O2, like these all reactions. Now, ikkada mana exothermic reactions kada. This is generally expressed. This is not thermochemical reaction. Plus heat is liberated. How much? 249 kilojoules. This is the expression of exothermic reaction. Now, H2, no need to expression of these physical states. Now, H2 combines with, okay, this is half mole of O2 to forming the H2O. Okay. Now here subtract the energy from the reactants. Minus 249 kilojoule gives rise to H2O. This is also expression of the exothermic reaction. And finally, thermochemical reaction. H2 gaseous plus half O2 gaseous gives rise to H2O liquid semicolon delta H is equal to minus 249 kilojoules. Right, children? Now, why we are giving the negative sign here? Let me discuss.
Given off, sir. Heat.
Given of heat. I think right. Okay. Now I am taking a graph. This is the graph what I am taking. Now observe this one. This is a enthalpy of reactant. This is enthalpy of reactant. This is a energy, means potential energy, PE, versus reaction coordination. Reaction coordination. Reaction coordination versus potential energy. Now, its energy increases, reaches the maximum, and to be converted as a product. This is the enthalpy of a product. Right, children? We know that enthalpy change delta H. In a chemical process, we know that delta H is equal to enthalpy of product minus enthalpy of reactant, children. Now, this is the value what I am taking, giving this one like this. This much of value. This is a 10, this is a 20, this is a 30, this is a 40, so on. Now, HP minus HR. This energy difference between these two, this energy gap difference between these two is expressed as a delta H. Now, product how much? 10. Potential energy in kilojoule. 10 minus reactant is how much? 20. Equals to minus 10 kilojoules. It's clear now?
Sir, can you explain once again?
Now, this is the enthalpy of reactant. నా పేపర్స్ నాకు సెండ్ చేయండి ఇచ్చేసేయండి నేను సాల్వ్ చేసి పెట్టేస్తాను రైట్ దిస్ ఈజ్ ఎంథాల్పీ ఆఫ్ reactant this much of energy potential energy heat content by the system This is heat, nothing but energy contained by the system at constant pressure is called as enthalpy, this much. So it gains energy, and to be converts as a product. To convert as during the course of the reaction, so this much of energy is lesser than that of the product, greater than that of the reactant. So this much of energy will enter to the system to surroundings. System నుంచి surrounding కి వెళ్ళిపోతుంది ఇది. Given off this much of potential energy. That change can be calculated. Delta H is equal to difference is how much energy is liberated. So 10 joules of energy is liberated. So lesser value 10 minus 20. So negative. So this value is not negative. This negative sign is indicating the energy liberated. Energy liberated. It's clear, na children?
Yes.
Yes. ఇక్కడ అంటే ఇంకొక రియాక్షన్ లో మనకి ఫర్ ఎగ్జాంపుల్ ఇంకొక రియాక్షన్ సేమ్ రియాక్షన్ మనం ఇలా తీసేసుకుందాం అనుకోండి. ఓకే, ఇలా వచ్చేస్తుంది ఆ రియాక్షన్ కి. ఫర్ ఎగ్జాంపుల్ అనదర్ ఎగ్జాంపుల్ లో తీసుకున్నాం. ఎగ్జాంపుల్ 2 లో 10 minus 30 ఈజ్ ఈక్వల్ టు -20 కిలోజౌల్ వచ్చింది. దిస్ ఈజ్ ఎగ్జాంపుల్ 2. నెక్స్ట్ దిస్ ఈజ్ ఎగ్జాంపుల్ 1 అనుకుందాం. ఇన్ విచ్ ద కేస్ మాక్సిమం ఎనర్జీ ఈజ్ రిలీజ్డ్?
Example 2.
1 or 2?
2. Example 1, sir.
Amma?
2, sir.
Right, children? So many students are think that, so this is a negative 10 is greater than -20. Numerically express చేస్తారు. No need to expression of numerical value. This negative sign is indicating the energy liberated only. This is the magnitude of amount of energy which is liberated. So here 10 kilojoules is liberated in this reaction. In this reaction 20 joules or kilojoules are liberated. So maximum amount of energy is released in example 2, not 1. Children, it's clear?
Yes, sir. Sir, if the product is more than heat is absorbed, sir.
Later we will discuss that one, children. Okay. Now for exothermic reaction, this is expression of already I told you, children, this is exothermic reaction expression. This is also exothermic reaction expression. This is also exothermic reaction expression. For exothermic reaction, enthalpy of reactant is greater than enthalpy of product. For exothermic reactions, enthalpy of reactant is greater than enthalpy of product. It's clear. Now observe, children.
Sir.
So no.
Sir, will you explain
No.
once again, sir? I
Which
lost
one?
my network.
This one, no? This graph, huh?
Graph. Yes, sir.
Right, children. Okay. Just during the chemical reaction, reacting species having a particular amount of energy at a particular temperature and volume or pressure. Now, this is the amount of energy is contained by reactant, means A. I am giving the equation A gives B. A is a reactant, B is a product. Just consider. Now, A gaining the energy gaining to be converted as a product, like this. During the course of reaction, increasing energy. During the course of reaction, increasing the energy reaches the maximum, forming the activated complex. Later you will know. Then it will be converted as a product. During the formation of product, it is liberating the energy. ఇక్కడ నుంచి ఇక్కడ వరకు no problem. Energy constant గానే ఉంటుంది. Now, this is the enthalpy of the. This is the enthalpy of. This is the enthalpy of product. Na means B. The energy difference between these two. Energy difference between these two is taken as change in enthalpy. Already we know change in enthalpy, product minus reactant. Product is how much more? 10. Reactant is 20. The difference is 10 minus 20 is equal to minus 10. And this much of amount of energy is released. Now, I am taking the second example. Another C gives D and C gives D. This is the enthalpy of C. To be converted as like this. So its energy is 30 kilojoule. Its energy is 5 anko. The energy difference between these two is called as delta H. Now product minus reactant, product is 5 for this example. That it is delta H is equal to 5 minus 30 is equal to minus 25 kilojoules. In which the case, this is second case, maximum amount of energy is released into the surroundings. Okay, rather than that of the first case. First case lo ee konchame kada release ayindi, konchame release ayindi. Second case lo ikkadi nunchi ikkadi variki in between energy is released. So maximum amount of energy is released in the conversion of C to D than that of A to B. It's clear, children. Understand, Amma?
Yes, sir.
Right. Now, okay. For exothermic reaction, HR means enthalpy of reactant is greater than enthalpy of product. Reminder, children, that it is a basic concept. Stability of species, any stability of any species is inversely proportional to energy. In the exothermic reaction, which is more stable, reactant or product? Which is more stable?
Product.
Product.
For exothermic reaction, exothermic reactions, product is more stable than reactant. Children, anybody doubt regarding this one? Anybody?
No doubt.
No, sir.
Changing the page. I am changing the page. Go to the next page.
Okay, sir.
Wait, sir. 1 minute. Sir, 1 minute. Sir, 1 minute, sir.
Okay.
Completed, sir.
Right. Thank you. Right. Now, endothermic reaction. Vasmi, tell me, endothermic reaction.
The reaction in which heat is absorbed.
Reaction in heat absorbed.
Means the chemical reaction or the reaction. The reaction employed are accompanied by absorption of heat, absorption of heat, absorption of heat from surroundings. Surroundings is called as endothermic reactions. Endothermic reactions. Banu, understand? Right. I am taking the one more example for this. For this one example is N2 plus O2 gives rise to NO. Okay. And how much amount of energy it is absorbed? That it is 180.5. Means the energy subtract minus 180.5 kilojoules. It's clear. Now, so in another manner, N2 plus O2 plus 180.5 kilojoules gives rise to NO. This is also representation of This is also representation of endothermic reaction. This is also representation of endothermic reaction. Now finally, nitrogen in gaseous state and oxygen is in gaseous state to give the 2NO is also gaseous state. For this process, delta H is amount of energy is absorbed must be signed with positive, that it is 180.5.
180.5 kilojoules.
It's clear now, children? This is the representation. Yes, this is also endothermic reaction representation in terms of thermochemical equation. Okay. So we are discussing already. I told you how to write the thermochemical reaction. I explained now, Banu.
Explain, sir.
Right. Now I'm taking the one more graph. Right, children. For this example, okay. For this example, now this is a energy of means potential energy versus reaction coordination. Reaction coordination. Right. Now, this is the enthalpy of reactant, means A for the example. The reaction is A gives B, my reaction. A gives B. This is the enthalpy of A. Now, this A is associated or gaining the energy reaches maximum and to be converts as a B. Right? Like this. This is B. This is the enthalpy of B. Right, children? What did you observe here? The energy difference between these two. Energy difference between these two. This is the energy of A. This is the energy of B. The difference between these two energies is taken as delta H. It's clear now? It is taken as a delta H. Now, for the example, this is a 10. This is a 10. This is a 20. This is a 30. This is 40. this is 50, this is 60, so on in kilojoules. So we know, children, delta H is enthalpy of product minus enthalpy of reactant. Enthalpy of product is noted like this: 40 minus enthalpy of reactant is 20. So that 20 kilojoule mole inverse. This is the positive side. Now, what did you observe here? Enthalpy of product is greater than reactant. Now, energy of means reactant is lesser than energy of product. అంటే ప్రోడక్ట్ ఎక్సెస్ ఎనర్జీ కావాలి కదా, ఎక్సెస్ ఎనర్జీ ఎక్కడి నుంచి తెచ్చుకుంటుంది? ఇట్ అబ్జార్బ్ ఫ్రమ్ ద సరౌండింగ్స్. సో దట్ బై అబ్జార్బింగ్ ద energy of this product will be greater. So that in case of endothermic reactions, enthalpy of reactant is lesser than enthalpy of product. Stability చెప్పండి తల్లి, stability. Since
Stability of reactant is
very good. For endothermic reaction, that it is stability of reactant is greater than stability of product. It's clear. Varshita, understand why we are using the negative sign, why we are using the positive signs. Signs are only indicating the energy is liberated or energy is absorbed, but the value is not negative. Okay, na? So this energy is liberated is always positive. Magnitude is positive only. The negative and the positive signs are indicating the energy is liberated or energy is absorbed. It's clear, na children? Clear?
Yes, sir.
Yes, sir.
Right. Now let me discuss about the factors that affecting the enthalpy of reaction. Shall I leave this place? Okay, no. Shall I leave this place?
Sir.
Yes.
Yes, sir.
Right. Now, factor affecting just 3 complete, 4 complete. Okay. Now, factors that affecting enthalpy of reaction or heat of reaction. Ignite which is not. Just wait, children. Just for this. This is a right. Now, first let me discuss about the heat of reaction or enthalpy of reaction. What is the heat of reaction or enthalpy of reaction? Let me discuss first. Heat of reaction. heat of reaction. Later we will discuss about what are the factors that influence the heat of reaction. This is also known as enthalpy of reaction. Enthalpy of reaction. Right, let me discuss. So heat of reaction or enthalpy of reaction may be defined as the amount of heat is evolved or absorbed. That means this process may be endothermic or exothermic. Simple. The amount of heat is evolved or absorbed when a quantity of the reactants completely reacted and converts as products is called as enthalpy of reaction or heat of reaction. Simply children, what I am explaining. The amount of heat is the amount of heat. The amount of heat. Heat is evolved or absorbed. The amount of heat is evolved or absorbed when a quantity of reactants completely reacted to form products is called as heat of reaction or enthalpy of reaction. Enthalpy of reaction. Anvita, understand? No?
Yes, sir, understand.
Yes, children. For the example, children, what I am taking for the example, 2 grams of gaseous hydrogen reacts with 16 grams of gaseous oxygen, okay, to form 80 grams of H2O in liquid state. During this course of reaction, okay, 286, okay, kilojoule of energy is liberated. Called as heat of reaction. Heat of reaction.
Sir, 249 no, sir. 249 no, sir.
This one, 286.
Okay.
And in the previous example, no, 249 అని ఉంది కదా?
Yes, sir.
That's the doubt. But observe, children, in that example, H2O is in a gaseous state. Did you observe? No.
Yes, sir.
But here the H2O is I gave you in which the physical state? Liquid. Means as a change in the physical state of the reacting species, enthalpy of reaction will be affected. Varshit, understand? Na?
సార్ అర్థం కాలేదు సార్.
Yes, sir. I understood.
Okay. In the above example, H2O I am taken in the gaseous state. In this example, H2O I am taking the liquid state. Now, ఇక్కడ గ్రాఫ్ లో ఏం ఫామ్ అవుతుంది తల్లి? Here this graph, this is a energy of the H2 and O2 forming this product like this. It's clear. Gaseous వచ్చినప్పుడు నీకు డిఫరెన్స్ ఎంత ఉంది నాన్న? Gaseous compound form అయినప్పుడు gaseous is greater energy than that of the liquids. Gaseous components has the greater energy than that of the liquid. So ఈ డిఫరెన్స్ కి నీకు ఎంత వస్తుంది? 249 వచ్చింది అనుకుంటున్నాను ఎగ్జాంపుల్. మరి ఇక్కడ లిక్విడ్ కదా కన్వర్ట్ అయింది. సో దిస్ మచ్ అమౌంట్ ఆఫ్ ఎనర్జీ, excess energy of amount of energy will be released. That can be 286. Understand now?
Yes, sir.
Right. So these are అంటే ఇలాంటి రియాక్షన్స్ మనని కన్ఫ్యూజ్ చేస్తూ అంటే డ్యూ టు ల్యాక్ ఆఫ్ బేసిక్స్ we are giving the negative or we have to left the answer. Perfect basic లేకపోతే ఆన్సర్ పోత్ ది నెగటివ్ అన్న అవుతుంది, లేకపోతే వదిలేయాల్సి ఉంటుంది. Basic concept. Basic is important. Right. Now, this can be explained on the basis like this. It's clear here. Now, H2 gaseous plus O2 gaseous gives rise H2O liquid state. For this, delta H is equal to minus 286 kilojoules. Okay, so this is called as enthalpy of reaction. So that this is denoted by delta H, subscript is R. R is indicating the reaction. It's clear, na children?
Clear, sir.
Yes, sir.
Now, what are the factors that influence the heat of reaction? Which factors that influence the heat of reaction? Let me discuss now. So completed, now going to the next page. Ma.
Completed, sir.
Rose. Now, factors affecting heat of reaction. Heat of reaction. Right. So first, which factors are first affecting the heat of reaction? Let me discuss. Among them, the first one is physical states. Physical states. So that first factor is physical states. Physical states of reactants, and products. Whatever reactant or product, whatever. Okay. Physical states, how they are influencing. So better example one. Example one. H2 gaseous plus O2 gaseous gives rise H2O gaseous. For this reaction, delta H is equal to delta H reaction
49
is
kg.
minus 249.0 na? Anyway, so okay, roughly I am taking the kilojoule mole inverse. In example 2, H2, same reacting species, physical state gaseous, half mole of O2 and half mole of O2, which is in gaseous, 2 forming the H2O, which is in liquid state. For this delta H for reaction is, tell me children,
286.
286.
generally I am taking 286 kilojoules mole inverse. Kilojoule mole inverse. As it changing the physical state, as it changing the physical state of, physical state is changed, physical state is changed, physical state is changed. The amount of energy is also changes. This is first explanation is completed. Now let me discuss about the allotropic forms of reactants. Simply allotropic forms of element of reactant. It's clear. What is its effect? Let me discuss it. Right. Now I am taking like this. Okay. For the example, I am taking the graphite. So carbon is in two different forms. One is graphite. Second one is carbon is in diamond form. Two different allotropic forms of carbon. Both combines with oxygen to forming the carbon dioxide. CO2 gaseous. This is also gaseous. Combines with oxygen gaseous to forming the carbon dioxide gaseous. Okay, children observe this one. In case of diamonds, so for this reaction delta H, for this reaction delta H, how it is variated? Let me discuss. Minus. This is 94.3. 94.3 kilocalorie. Here 97.6. 97.6 kilocalories mole inverse. Here is also number of moles, 1 mole we are taking. So what did you observe, children? Here, what did you observe? I observed is as it changing the allotropic form of compound, allotropic form, okay, no? And its energy, enthalpy of reaction is also changes. So allotropic forms can affect the enthalpy of reaction. Children, it's clear?
Yes, sir.
Right. Next, I am going to the another effect, that it is temperature. Shall I leave this place?
No, sir. 1 minute.
Sir, you can leave the page.
Right. Now, effect of temperature. Effect of temperature. Now, as a changing, let's see, as changing, as a changing temperature. Heat capacity is also changes. Heat capacity is also changes due to which heat of reaction is also changes, so that the heat of reaction expressed in terms of standard heat of reaction, or standard enthalpy of reaction, which is denoted by okay, delta H R naught. క్లియర్ నా? ఇక్కడ నాట్ కనిపిస్తుంది అంటే మనకి వాట్ ఈస్ ఇట్స్ మీనింగ్? స్టాండర్డ్ కండిషన్ ఈజ్ ఎక్స్ప్రెస్డ్ ఇన్ ద స్టాండర్డ్ కండిషన్స్. సో దట్ లెట్ మీ డిస్కస్ స్టాండర్డ్ కండిషన్స్. Okay. So standard temperature in thermodynamics is 298 kelvins or 25 degrees C. Standard pressure if we take either 1 atm, 1 bar. These standard conditions. If the chemical reaction is employed at 298 K and 1 atm pressure, okay, the heat of reaction, the heat change is called standard heat of reaction. Children understand now? As it's changing the temperature, heat capacity of the system means reacting species as well as products is also changes. That's why the amount of heat is evolved or absorbed is also changes. So that the temperature must take the enthalpy of the reaction, due to which this heat of reaction can be explained on the basis of the standard enthalpy of reaction. Before going to discussion of the standard enthalpy of reactions, we may explain the first standard conditions. Standard temperature is 298 kelvins or 25 degrees C, and standard pressure is 1 atm or 1 bar pressure. So if the reaction or chemical reaction is employed, nothing but it takes place at 298 kelvins and 1 atm pressure, the heat change is called as standard heat of reaction, delta HR naught. Naught condition is expressing the heat of reaction. Children, it's clear now? Clear?
Yes,
Is
sir.
anybody? So going to the next page.
Yes, sir.
Yes, sir.
1 minute, sir. Last.
Okay.
Sir, we can say this as room temperature, sir.
Yes, simply it is called as room temperature. But mentioning is important. In some cases, room temperature is taken as 25 degrees centigrade. In some cases, room temperature is taken as that it is 27 degrees centigrade is also. But practically, standard conditions is 25 degrees. Standardly, we are taking. So, is it completed?
Yes, sir. Complete.
Now, correct. Now, reaction carried out at which the situation. Okay, reaction carried out. Next factor, that it is, I think, fourth factor now.
Yes, sir.
Reaction carried out at which the situation carried out at a constant volume or pressure. This is also affect the enthalpy of the. This is very useful understanding by solving the problems later by using the bomb calorimeter in the calorimetry. Later we will discuss that. Now, so children, I am explaining like this one. Okay. If the reaction, if the reaction taking place at a constant volume, the heat change is called as heat of reaction at a constant volume. If the reaction takes place, if the reaction takes place at constant volume, the heat change, is called heat of reaction at constant volume. Simply change in internal energy. Whereas in a constant pressure, whereas at a constant pressure, it is called as
Enthalpy.
heat of reaction. At constant pressure. Delta H. Remarkable point. In case of reactions of solids and liquids. Okay, the heats of reactions at CV and CP, constant volume and constant pressure is constant volume and constant pressure. The difference is negligible. Whereas in gaseous components, it is considerable. So that delta H, delta U. Now they are interrelated with delta H is equal to delta U plus delta N. Okay, delta H is equal to delta U plus delta N. Children, it's clear? Clear now?
Yes, sir.
Already we know that what is delta H, what is delta U, we know that. Right, children. Now finally, the fifth factor is quantity of reactants. So this enthalpy is an extensive property. It's a compulsory depends upon the quantity of the system. So that maximum quantity, maximum enthalpy of reaction, minimum quantity, minimum enthalpy of reaction. So that enthalpy of reaction, enthalpy is extensive property. So that delta H depends on quantity of reactant. Example what I am taking, children, for example, okay, 2 grams of H2 plus 16 grams of O2 gives rise 18 grams of H2O. Delta H is, for example, I am taking liquid, for example, 286. In case I am taking the 4 grams of H2 and 32 grams of O2, then 36 grams of H2O liquid state. Then 286, okay, that it is 572 kilojoules. This is the kilojoules. Here quantity is increasing, heat of reaction is also increases. Children, it's clear now? Come on.
Sir, what is of extensive properties?
What is?
Sir, in quantity of reactants, enthalpy is extensive property. After that, what is this?
So that delta H depends on quantity of reactant. Banu, it's clear, Amma?
Clear, sir.
Yes, sir.
Okay, children. Now going to the next. ఇక్కడ నుంచి depth start అవుతుంది తల్లి. Most of questions are asking based on types of enthalpies of reaction. మనం enthalpy of reaction చదువుకున్నాం. We completed. Now how it is affected by the different factors. We completed. Now let me move to the how many types of enthalpies of reactions. Enthalpy of formation, enthalpy of body dissociation, enthalpy of combustion, enthalpies of sublimation, enthalpy of vaporization, enthalpy of condensation, enthalpy of phase transformation, So many types: enthalpy of neutralization, enthalpy of dilution, enthalpy of dissolution. These all are there. So among them, some are significant. Okay, enthalpy of heat of hydrogenation, most important for AIMS level questions are asking. Number of times in AIPMT, questions are asked over the enthalpy of hydrogenation or heat of hydrogenation. That questions will be discussed with children. Right. Shall we leave this page?
Yes, sir.
Right. Types of heat of reactions. Heat of reactions are enthalpy of reactions. It's clear. Let me discuss what is the enthalpy of reaction. Already we know. How many types are it is? Let me discuss. Now, among them, the first one is children. Among them, the first one is okay, that it is enthalpy of formation. Enthalpy of formation. Most important for NEET questions are asking from this one. What is enthalpy of formation? Let me discuss. Before going to discussion of this one, 2 to 3 times I have to explain the definition. What is the enthalpy of formation of reaction? Enthalpy of formation of reaction means the amount of heat is evolved or absorbed. The amount of heat is evolved or absorbed when 1 mole of chemical substance is formed from its constituent elements of their most stable form is called as enthalpy of formation. Right, children? Now I am writing this enthalpy of formation. So ఇంకా నోట్ చేసిన తర్వాత అయితే ఇంకొంచెం ఈజీ ఉంటుంది అనుకుంటున్నాను నేను. చూడండి, the amount of heat the amount of heat is evolved or absorbed. The amount of heat is evolved or absorbed when ఇక్కడ చూడండి 1 mole మిమ్మల్ని కన్ఫ్యూజ్ చేయడానికి వాడు 2 moles ఇచ్చేసి ఎంథాల్పీ ఆఫ్ ఫార్మేషన్ ఫైండ్ అవుట్ చేయండి అంటే మనం అదే ఇస్తాం ఆన్సర్. All enthalpies are respected or expressed in terms of 1 mole only. Only 1 mole. 1 mole ke consider cheyali. It's clear. So the amount of heat is evolved or absorbed. Ante enthalpy of formation may be exothermic or endothermic. We don't know. Whatever the process, it is depends upon the nature of reactants and the products. Now, is evolved when or absorbed when 1 mole of, this is important, 1 mole of chemical substance or compound, chemical substance is formed is formed from its constituent elements of their
Most stable states.
is of their most stable form or state. Most stable form. Most stable form is called enthalpy of reaction. Definition ni any time చదివినా no problem. By heart చేసేసుకుంది. This is the most important definition. Enthalpy of formation. Right, children? Now I am taking like this. This is the delta H kada enthalpy. Okay, enthalpy of formation F. It is denoted by enthalpy of formation. Is clear? Right. Delta H subscript ఏం తీసుకున్నాం నాన్న మనం రియాక్షన్ కి అయితే R తీసుకున్నాం ఫార్మేషన్ కి ఏం చెప్తున్నాం మనం F. It's clear. Now for the example what I am taking, so H2 gaseous state stable form plus oxygen 1/2 most stable form gaseous 2 forming the H2O. నేను లిక్విడ్ స్టేట్ చేసేస్తున్నా దీంతో నీకు సంబంధం లేదు ఇక్కడ 1 మోలే రావాలి 1 మోల్ ఓన్లీ ఫర్ దిస్ రియాక్షన్ డెల్టా H ఫార్మేషన్ ఈజ్ ఈక్వల్ టు -286 kilojoule molecules. Children understand? Understand? Right. I am taking the one more example for contradictory of this one. Now CH4 means carbon graphite plus hydrogen gas to form CH4 gases. For this reaction, delta H formation.
-74.8.
Oh, minus 74.8 kilojoule molecules. Most stable form ni consider cheyali. Otherwise, it is not considered. For example, carbon, okay, diamond plus oxygen gives rise CO2 gaseous. For this one is 395.5 kilojoules in one. So here this is a minus value delta H. It is not considered as enthalpy of formation of carbon dioxide. Enthalpy of formation of carbon dioxide ki reaction it is not the correct representation. Why? Because carbon is a most stable form means graphite, but not a diamond. Varshit understand?
Yes.
Varshit understand now? Tell me. So according to the definition says the amount of heat is evolved or absorbed. Means it may be either exothermic or endothermic, whatever the process. Exothermic or endothermic. It's clear. Okay, evolved or absorbed. When 1 mole, compulsory 1 mole of chemical substance from its elemental state is compulsory. Of their constant elements compounds form over of their most stable form. These points are most important for this regarding. Children, it's clear now? Clear?
Yes, sir.
Right. So this is our class for today. Next, we will meet in the next class. So some regarding that means children, once again, this is the most stable form I am explaining some compounds. For carbon, most stable form is graphite. Carbon, graphite is most stable form. Okay. In case of sulfur, allotropic forms.
It's
Okay.
8.
For rhombic. In case of phosphorus, it contradictory. Most of the books are giving the red phosphorus is the most stable. So that ozone and oxygen ki two different allotropes ఉన్నాయి. O2 and O3. O2 is the most stable form. It's clear? Na? O3 is the less stable. O2 is the most stable form. It's clear, children. So this is our class for today. Next we will meet in the next class. Okay. Thank you, children. So that
Thank you, sir.
There is